Okay, here we go. Attempt number 4 is a go. Hey guys, what's up? How you doing? It's me, J-Doe, and welcome back to Universe Sandbox². Just as I said, this is my 4th attempt at recording part 2. Mainly because, due to some factors. Number 1, the first factor was I tried recording this and so much skipping. I couldn't handle it in the editing process and I decided to abandon that take. Second try, my voice couldn't record. For one part, I couldn't sync. And third try, more skipping. Now, I've just adjusted some settings on my Bandicam, and hopefully this one should work out well. Thank you so much for the support in the last one, if you have already seen it. And if you like this one, make sure you leave a like. I hope to make more of this soon, because this game is awesome. Now, with that said, you can see a little bit of the solar system. And these little fragments here and there just roaming around. Just waiting to see. Looks like 2010 OEK 139 is making its slow descent towards the closer planets. But I don't see why it wouldn't hurt to get a little more out of the way. Now let's go to the tutorials and lessons and see what we can get out of this. Are you ready? Here's another tutorial. Using the Add tool is the easiest way to create and interact in Universe Sandbox². You can use it to build whole systems from scratch or to rip apart Saturn's rings. To rip apart Saturn's rings, eh? Like what would I use? Neptune? Some random asteroid that could knock into one of the fragments featured in Saturn's rings? I don't see why not. I could see that happening. Maybe I can find a simulation of it somewhere. Now let's add, when building a solar system, it's easiest to start with the objects with the most mass, in this case, a star. And I am going to choose, for the last 3 takes I chose 1, and unfortunately, if you can guess that one, then I'm going to pick a different one. I'm going to pick Proxima Centauri. It looks like it's similar to the Sun in a sense. Our Sun, considerably. But, yeah. Close in color, just not quite as much. And whereabouts in the empty space can I click? I shall instead click over here. And now let's put some planets in orbit around this star. From the looks of it, you can see it's very bright. And then we will select a random rocky planet. The planet chosen is... Janius, is it? I want to put it some nautical miles away. How many nautical miles are we looking at? Oh, astronomical units. Keep it 1 astronomical unit away, because then, there. Now try adding a planet with a tilted orbit. We now have Iov, and we'll put that start at 2 astronomical units away, tilt it up, give it a tilt enough to give it 2 1/4 astronomical units away from Proxima Centauri. You can select different add options to change the object's starting velocity. We'll explore these options in later tutorials. You can use the search bar to quickly find what you're looking for, or to search Universe Sandbox²'s database of over 50,000 known objects. Now try searching for an object like... Wait. I'm not supposed to say that, but Kepler-62e is an exoplanet similar in size to Earth. There's another planet, Venus, which is supposedly Earth's dead twin, if you will. You can see why if you do some research, but I'm sorry I'm being rude just by forcing you to Google something, but in the meantime, let's just look for the planet. Many of the database objects only have technical names, but if you know the designation for a specific known object, there's a good chance you'll find it if you search. Yeah, we'll look into that. Now try experimenting with adding different types and sizes of objects to see how it affects your solar system. Can I add a planet? I'm going to add Kepler-62e. and send it 1.5 astronomical units away from Proxima Centauri to see how it fares out. Now, how does this affect our solar system? Is it even moving? Huh. Let's set the timestamp to 200 hours a second, like a week a second. Is this going to affect the solar system as it stands right now? And if we look at Iov in the distance, I doubt it's probably going to hit Kepler-62e very soon. Genesis is... or is it Genesis? Genesis? My vision is fucked. Let's try launching objects. That's gonna always be fun, isn't it? No experience of Universe Sandbox² is complete without launching one planet or another and watching the fiery chaos unfold. Fortunately, there are a few easy ways to do exactly that. And here we go. Prepare to strike the enemy. This is your captain speaking. We are about to take fire on an unknown planet that is detrimental to our system. Take aim and fire! Breaking news, shots fired on Mars! You can launch any object in the add panel, yes, even stars and black holes. You can also launch objects using the 1 to 8 keys on your keyboard. Aim at Mars again, then press 2 to launch Mimas. And Mimas away! You can hear the explosion as it hits Mars. Now select the launch filter to view which object is assigned to each 1 to 8 key. Now let's customize it so when you press 1, you select a random rocky planet. Oh, guess what? It was already assigned the last 3 times. Now every time you press 1, you will launch a randomly generated rocky planet. You can assign any object to any of the 1 to 8 keys. A convenient shortcut if I wanted to, say, launch a gas giant at a smaller planet. That would be destructive and chaotic. Enjoy the destruction. If you prefer something more nuanced, try loading the Saturn's ring simulation and launching a Neptune to distort its rings. It would work, but there's already a Saturn and Neptune simulation that I've already seen, and I will show it to you once we finish up some more tutorials. And we'll see a light pulse! The light pulse tool launches a ring of particles which travels at the speed of light. It's a great way to gain an intuitive sense of just how vast our universe is. The light pulse is best seen when the simulation is running in real time, so let's change the time step. Let's see. And hold on, let me adjust my volume on my headphones. Shut up! Is that good? Good. You can use the time step slider to slow down time, but let's use a shortcut. And the time step will be dropped to 1 second. The light simulation is now running in real time, or 1 simulation second per 1 real-time second. It seems obvious to me. And let's click the pulse. And here we go. Let's try and aim for the center of the sun. And a beam of light shall be shot now. I will launch a couple more, just to get a feel of how this works. These don't look like they're moving fast, but these particles are traveling at the speed of light. It will take them more than 8 minutes to reach Earth, and in 5.5 hours, they will pass Pluto. You can select between ring and sphere, adjust the number of particles, and change the velocity in the light pulse settings. So we get the idea of how a light pulse works. But last time when I tried launching a sphere from the sun, total lag. My recording. I wonder what a pulsar does. Is that like a lighthouse? Because it's like beep, beep. Yeah, that's how what I get the image of when I see when I feel like when I get a pulsar, or when I get the image of a pulsar, because that's what I think. Lighthouse, heartbeat, those kind of things. And I hope it's the same here. Pulsars are fast-spinning, highly magnetized neutron stars. As I thought. Their beams of radiation sweep through space like cosmic lighthouses. Let's make one, shall we? You can use either a neutron star or a white dwarf to make a pulsar. For this tutorial, let's create our pulsar using Sirius B, a white dwarf. Now let's add it to the simulation. If anything, we will find it. And shortcut, as I learned, the search feature provides all the answers. And instead of launching, I will send it to orbit. Oh, and guess what? Take a look at this. You put two of them together, it creates a supernova. Exactly how one recording can fuck up. Now let's close our add tool just to make sure we don't launch any more Sirius Bs. And we click on the mini info panel. Materials. And magnetic field. Let's see, where is, here it is. I will enter 10 to the 12th Gauss. Just because it says there. Typical value. And top. Zoom out to observe the effect. Oh, would you look at that? Now let's create the pulsing lighthouse effect. A value greater than 3 degrees, huh? 3 degrees is the best option, but for my pulsar, I want to make it a, can I adjust this? 30 degree pulsar, baby. 30 degree. And let's make it spin faster. And, up. We do not want that, do we? The pulsing effect is best seen with low time steps, close to real time. And we are in real time. Experiment with different values for magnetic field and angle and try viewing it from different perspectives. Oh, what the fuck? Oh my god, that magnetic field though. That is so blinding. That is way blinding if I can tell you right now. Now let me just experiment again. If I can find the materials, let me find the magnetic pole angle, and let's set it to the minimum it can be, 3 degrees. Oh. Not as bad of a rotation compared to 30 degrees. I dare you guys, if you have this game, try making a light pulse out of the sun. Set the magnetic field to something like 10 to the 12th, or somewhere around there, and see if you can get a spinning lighthouse effect. Oh my god, my girls are interrupting me again. When will they stop? Don't you just love them? And finally, objects and trails. Their colors. Let's see if we can adjust that, shall we? Coloring objects and trails by their mass, acceleration, and velocity is more than just a nice visual touch. It's also a great way to gain another perspective on orbital physics. Alright, and you can see how the colors of the trails are reflected by the colors of the planets themselves. Like, for example, Earth is blue because it's mostly water, whereas Mars it's red because its area is mostly land. That's rock. Just pure red rock. But if we adjust the velocity, take a look at what the colors do now. It's easy to see that the objects orbiting closer to the Sun are moving faster. For example, Mercury is red, and Eris, one of the objects furthest out in the simulation, is blue. If we can find Eris, like it's this big planet way out there. You can toggle colors on any simulation. Fragments and particles are also colored, so be sure to try it out with collisions and rings. For the sake of seeing what color Eris is, I'm going to go back to realistic. Eris is actually at an orbital angle, which is fun, in a sense. Let's go back to Earth real quick. Oh my god, would you look at this? Yep. It even shows you the velocity colors already on here. It kind of makes sense, doesn't it? The next thing I want to show you, and the last thing I want to show you, is earlier in the tutorials we shared an idea of how Saturn's rings can be distorted. There is, in fact, a simulation based off of that. And it's Saturn and Neptune. If you take Neptune and put it close to Saturn, watch what happens to Saturn's rings. Some of them hit Neptune, others land in Saturn. And others well, let's just say that some others are just going lost in the atmosphere as it already is. And we'll never see those rings again. You can see just how much chaos Neptune is causing to Saturn's rings as of right now. Some of them are just going into Neptune's orbit as it already is. And just chaos, utter chaos. So that's going to do it for today's episode of Universe Sandbox². I hope you enjoyed this episode, and if you want to see some simulations going forward, especially with the upcoming tutorials, please let me know in the comments. I would love to see how some other things occur. You've already seen galaxies collide, you've already seen how 6 moons can collide into Earth and just cause it to just be destroyed with absolutely big-time deaths. And on top of that, what you're seeing right now, Saturn and Neptune's rings. Saturn's rings getting distorted by Neptune itself, getting caught in between orbits, and what do you know? Explosions abound. Anyway, thank you guys so much for watching. Don't forget, leave a like, share this video with your friends, and as always, I will catch you guys in the next one. See you next time, everyone! Hey guys, if you like that video, make sure you check out these other 2 videos over here. Last part of this video, maybe another video you might like. Also, don't forget to check me out on Twitter for more updates. I'll be posting links to my videos from there, if you want to get them first. And don't forget to leave a like the buddy said, post your comments, and don't forget to subscribe to the YouTube channel if you want more videos like this. Obviously one. Thank you for watching, and I'll see you next time. Also, please watch out for any squirrels on the way out.